Bisection method is a way to solve nonlinear equations through numerical methods. Besides, bisection method relies on defining two inputs between which there is a known root. Hence, to solve a nonlinear equation which is now have a quadratic equations, we will use a bisection method by implementing the bisection method in Excel.
So let's assume that A is always going to be our lower boundary and B is always going to be our higher boundary. C is going to be our midpoint value, which will be based off of our A and B values. F of A, F of B, and F of C will be found using the function's output, which we are solving for. Next, we need a column that determines which of these two outputs, F of A times F of C, and F of B times F of C, gives a negative value, and this will tell us which direction we need to move in, whether it is left or right. Then, lastly, we just need to calculate the error at any given iteration, which is simply our higher boundary B minus our lower boundary A. Now, for the first iteration, we need to assign A and B values based on what we found in our positive or negative product test that we performed in the previous iteration. To accomplish this, we are going to use a simple if statement. So to do so, we type equals if and then a logical statement. So that means something will either be true or false. So we select the value given by f of A times f of C and test if it is less than 0. If true, that means our root is to the left of our midpoint and A will remain unchanged, whereas B will take on the midpoint value. If false, then the root is to the right of the midpoint and A will take on the midpoint value. We repeat the same formula for our higher root boundary B. Now, we are free to bring down all of the other rows, and every time we create a new row like this, we are basically iterating another step. Now, we are done, but we could plot a nonlinear function in Microsoft Excel, also visually depict our function in boundaries in the following way. Create small steps in the x direction. Let's say 0.01, and we will go from our initial boundaries of 0 to 1. Then, beside this, we can apply these inputs to our function, and we get the outputs. We can graph the function and visually see that we do indeed have a root between these 2 points, 0 and 1. Let's create 2 points in space to visualize our lower root boundary at iteration 5. So, using the same x-axis and some arbitrary higher and lower y values, we can achieve this vertical line, and we just repeat this for our higher root boundaries. And there you go. We have just completed a problem using the bisection method in Microsoft Excel. One additional thing that you can do, and is really cool, is to add a validation that we have a root within two boundaries. So to accomplish this, let's create an if-or statement which states that if f of A times f of C or f of B times f of C is less than 0. We can print true, there is at least one root present, and if it is false, we can print false.